Hi guys, my name's Tenny, and in today's video we're going to be talking about Calculus Basics 101. Now, there's three main parts of calculus. The first one we're going to be talking about is limits. Now you use this whenever you have a function. And limits, the definition is as x approaches, or like any variable, approaches a value. Alright, so say we have this expression x squared minus 9 over x minus 3, and just say x equals 3. So then we'll have 9 minus 9 over 3 minus 3. But that equals to 0 over 0, which is undefined. Now this is where limits comes in. Limits, so we can say as x approaches 3. So we can use, let's just say 2.9. 2.9 squared minus 9 over 2.9 minus 3, which will equal to, let's just say, negative 0.59 over negative 0.1. And this will equal 5.9. And we can do the same thing for 3.1. So it'll be 3.1. So we do the equation 3.1 squared minus 9 over 3.1 minus 3. Yep. Now that will equal 0.61 over 0.1 equals 6.1. Now, we can do this for infinite times. Keep going, like let's just say we can go 3.01, 3.001, and same thing for 2.9, 2.9, 2.99, 2.999. So let's just do 3.01 for now. In the end, it'll equal 6.01, I'm pretty sure. And for 2.99, it will equal 5.99. As you can see, they're getting closer to 6. So that means the function will be 6. Now, let's talk about the next part. Derivatives. Derivatives are very useful. Say you have a graph, and derivatives help you calculate a point of change in a single instantaneous moment of time. But before you need to learn this, you need to know two things. The tangent line, which is a line touching the graph at one point in time, and the secant line, which is a line touching the graph at 2 points. Okay? Now, for derivatives, let's say, quick question. Let's just do an example. So, let's just say we have water filling up a tank, and let's say T is the minutes, while A of T is the liters. So let's say the thing is A of T equals 0.5 t squared plus 0.2 t plus 100. Got it? So now, we have to find the derivative of this, first we'll draw it. T, and our question is, we have to figure out how much water is in it when t is at 0, 9, 10, 11. Now, our aim is to figure out by what rate is the water changing when t equals to 10. So, okay, now, what we have to do is to find the derivative of this. So say you have a number, say it's x cubed. Or we can also use x, and we can also use a constant. Now just remember that this will always equal to 0 if it's a number, if it's just a number. Then, if it's x cubed, we bring this over here, 3x. You keep this there, so it'll be 3, and then you minus 1. So that will be 3x cubed. For this, power of 1. So, it'll be 1x to the power of 1 minus 1. 1 minus 1 is 0. So, in the end, it'll just be 1. Okay. What we have to do is to find the derivative of this, which in sign is called a, and then you do like this little apostrophe. Yeah. So let's find the derivative. So it'll be 0.5, and there'll be 2t to the power of 2 minus 1, or to the power of 1. So it's the same thing as saying to the power of 1, or just 2t. Plus 0.2 1t to the power of 1 minus 1, or 1t to the power of 0, which is equal to 1, plus the derivative of 100, which will be 0. Now, t, we're trying to find t when t equals to 10. So it'll be 0.5, 20, plus 0.2 equals 10.2. Alright, so that is the rate of change in which gallons are going at the minutes when t is equal to 10. Let's talk about integration, which is also called antiderivatives. So now that we're up to integration, let's say we have this. Bam. Let's say we have this, 3 and 1. So we'll just do something simple like x squared dx. So you need to find it as x approaches 3 to x approaches 1. So to find the antiderivative, you do this. So you go x 2 minus 1, so you do that, but you do over this, so 2 minus 1. Oh wait, no, sorry, plus 1. So say x equals 3. So it'll be 27 over 3, that will equal 9. So the answer to this is 9. Yeah. Now, say we have the same thing that we had last thing, so it was like Pretty sure that was it. Now, instead of trying to find when the water changes at, let's say, T equals 10, now we're trying to find the accumulation of water when T equals 9 to when T equals 11. Alright, so let's just say we draw a quick graph. So we're trying to find out the accumulation of water here. Now, what's that? To do this, you have to find the integration of this. So it'll be T squared plus 1 over 2 1 plus 1, which equals T over 3. Now, if you do this for T, it'll be T1 plus 1 over 1 plus 1. So it'll be T squared over 2. And then we find the integration of 100, which will be 100 to the power of 2 over 2. So that will equal 500. Now, to find the accumulation, we have to plug in 11 as T minus 9 as T. Okay, so then we'll go 11. So that will be T3 over 3 plus T2 over 2 plus 500. And we need to put 9 in these and 11 in these, and then 11, we'll do the 11 one minus the 9 one. Alright, so we got, the first one we got 1004.1. 1004.1. That's the answer. Overall. So now we can erase this and say 1004.1 approximately. Then we minus and we do the same thing and we put 9 into this. So we'll go equals 793.5. 793. And then we do this, which will be 210.6.
5.
So this is what it accumulates to. So this is just a basic overview of calculus.
W teacher chat. W teacher chats.
Please make sure to like and subscribe